Hello students, today because of network issues we are unable to take online class and I am taking offline class today for you all. So today's class will start, we will start. Before going to start, just let us close our eyes and we'll do prayer, then we can start. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. All right. So now we are going to discuss about Venn diagrams. Before going to discuss Venn diagrams, what we discussed in your previous classes, listen this carefully. So we will revise it. So what is set? We discussed set is nothing but a well-defined collection of objects that we discussed, and then how to represent the sets. So how many forms? Two forms are there: roster form, set builder form. So that we discussed, and then what is open interval, what is closed interval, what are the different types of sets are there, all sets we discussed. And then different types of operations also we discussed. What are those? What is union, what is intersection, what is subtraction, right? So then what is union, what is intersection, for that properties also there. For that all the properties with the examples we were discussed in the last class, right? So today we are going to discuss how to represent sets in a diagrammatic form. So why this is called as a Venn diagrams? So first thing you need to remember carefully, the diagrams which we use to represent sets and operations of sets. So operations on sets. So to represent the diagrams which are used to represent sets and operations of sets, those diagrams we can call it as Venn diagrams. Then you may ask, why sir we will call this as a Venn diagrams? So this is one of the famous English mathematician. His name is John Venn, who was used first to represent in a diagrammatic form. Okay, so who used to represent in a diagrammatic form as a groups or the sets. So he used first diagrammatic form. So to honor him, we kept the name as Venn diagrams to the diagrams. So here once again listen carefully, the diagrams which were used to represent a set. So that diagrams we can call it as a Venn diagrams. The reason behind this it is why we will call as a Venn diagrams. John Venn, English mathematician, who was used first, because of that reason we will call these diagrams are Venn diagrams. Now we can understand what is Venn diagram and which diagrams are used. Okay, so let we understand which diagrams are used. Everyone observe carefully on the board. So let you all understand clearly. So first, here are some of the things we have to discuss. So here first it is, what is universal set, how we will represent universal set. You already know that all the subsets together is there in one set, then that is called as universal set, or it needs satisfied some of the conditions and those all. So we discussed what is universal set previously. Now we need to discuss how to represent this universal set in a diagrammatic form. Universal set is represented in a diagrammatic form as a rectangle or square. Okay, so you may represent with rectangle or square. Clear? So universal set, if you want to represent as a Venn diagram, you have to represent as a rectangle or as a square. Okay, so now we'll discuss how to represent a set then. So sets in a inbuilt whichever is there, those how to represent now. Let me check the set. How to represent a set. Any set will be represented with circle with circle or oval shape or oval shape. So listen this carefully. Set is represented with a circle or oval shape. So next what we need to discuss in this place, if circle, if it is represented, then how to represent elements of sets. Elements of sets. For example, it is set A, it is also set A. So here numbers are 1, 2, 3 is there, 1, 2, 3, but you need to keep here dots. When you keep the dot, that indicates that it is an element. In this way you have to represent in the diagrammatic form. Here also 1, 2, 3, 4. Like this you need to represent in a set the elements. Okay, elements of sets are represented in a set in this method in the Venn diagrams. And this is this circle represents set A, and this oval also represent with set A. You may use circle shape or the oval shape, that is your wish. So that is about your set, and now we will understand how to represent A union B, A intersection B, A minus B, those are, so that you can understand clearly what is that concept, right? So we'll discuss about that concept now. Okay, so now first we are going to discuss this, what is A union B, how to represent A union B. Or first you want to know how to represent set A. First set A, if universal set is given. So what we need to do is, you need to draw first universal set and set A. Okay, so this is representation of a Venn diagram, representation of set A. So it is a representation of set A. Now how to represent A union B? Union means what? Combining. So just observe carefully, your U and A is here, B is here, combined both. And combine means what we need to do, just I'll draw some lines, then you can understand. So A and B both included. So now we can write A union B is equal to this lines wherever is there, that is called as A union B. Now I want A intersection B. How to represent now A intersection B? Check now. So A intersection B. Intersection means common elements. So again draw rectangle symbol. So you draw properly in your books. It is union set A. Now I use two oval shapes, A and B. Intersection means which is the common part. So in this place you found this as our common part. So I can write here it is. So this common part is called as A intersection B. So if you want to represent, just you can draw like this, a rectangular box or square box, draw lines that is equal to keep as A intersection B. Clear now? So here now you found A union B, next you found as A intersection B. So now we are going to discuss what is A minus B and then B minus A. Okay, so let we discuss now first A minus B. Okay, so let me discuss. Okay, so first we'll find what is A minus B. So without elements we are discussing now diagrams, okay. Next we will discuss with the elements, okay. So now here it is A set and next one it is your B set. I want A minus B. A minus B means, so B completely remove from A. So complete this B remove, okay, with the common elements. So whichever left, that is your A minus B. So what I'll write here, just observe carefully now. This is A set. So whichever the lines vertically is there, that is called as A minus B. And now what is B minus A? So B minus A is nothing but which are the horizontal lines is there, that is B minus A. And here one more also will represent what is this part. This part is A intersection B. So I hope you all understood what is A minus B, what is B minus A, what is A intersection B in one. Okay, so that is about that. And now we will take some examples and we will solve it. Okay, so let me go for those. And then which are the some important Venn diagrams also we'll discuss. So we'll take some examples. Then you can understand again how to represent if elements is given. So let A is equal to 1, 2, 3, 4 given, and B is equal to they given 3, 4, 5. Okay, and the one U is equal to they given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how to represent this in the Venn diagram? Here you need to find A union B, second one A intersection B, third one A minus B, fourth one B minus A, and fifth one A union B complement. Okay, so you know that U minus A union B. Next, sixth one A complement U minus A. Then seventh one B complement, that is U minus B. And eighth one we are going to discuss as A union B, A intersection B complement. That means U minus A intersection B. Okay, these all we are going to discuss and we can understand it. So after completion of this, so your whole representation will complete, and what are the important diagrams that we are going to discuss. Okay, so now let me go for first A union B. So let me draw first here. So this is your A and this is the B. And what are the common elements for A and B? 3 and 4. So write here 3 and 4. And which are left? That right here in the B. And here 1, 2. And which is the left? 1, 2, 3, 4, 5. 6, 7, 8, 9, 10 will be out. 6, 7, 8, 9, 10. And this should be your universal set. Now, from this, what you are in this, now we need to find first A union B. So let me draw for A union B diagram now. Okay, A union B, A, and this is your B. 1, 2, 3, 4, 5. So 6, 7, 8, 9, 10. So to represent as a Venn diagram means just draw the lines. So I drew it and I written now here A union B is equal to these lines. Okay, I hope you are understood what is A union B. Now we'll go for A intersection B. So let me rub here this Venn diagrams. Anyhow, I was represented everything in this place, so no need this part. So here and this I am going to draw it. So A intersection A union B completed. Now I will go for A intersection B. So let me draw the diagram. Always rectangle. So union. Now first take A and then B. AB, and what are the elements? 3, 4, 5. 1, 2, 6, 7, 8, 9, 10. Right? So now what I need to do in this place? A intersection B I want. Intersection means which are common. Common elements are this. So just draw here only the line and then represent here that is equal to A intersection B. Clear? And now we are going to discuss what is A minus B. Here itself I am going to represent A minus B also. A minus B is equal to completely, which is remove A. A minus B means completely remove B. Completely remove B. So what I'll do here it is, completely if I remove B, that means this full part is removed. What is left? Only this cross line part. So draw this cross lines indicates that A minus B. And now next B minus A. B minus A also here only I am going to represent. You just observe whichever this horizontal lines are there. Horizontal lines, that is your B minus A. Because here completely A is removed. So only these lines, whichever the part indicates, only B, that is. So B minus A, after you removing the common elements, whichever is left in the B, that is called as B minus A. So now you found A intersection B, A minus B, B minus A. Now we are going to find our A union B whole complement. So we are going to understand what are these complements now. Okay, so now first, again draw your diagram. Universal set. What are the elements? 3 and here 4 and this 5, this is 1, this is 2, 6, 7. You can write anywhere, that 8, 9, 10. Okay. After writing this, A union B complement. That means what? Remove total A union B from the set, from the universal set. So that means here these lines I'll keep. So except this part, remaining all. So that means what we can write, all the empty space whichever is there, that is nothing but A union B whole complement. Clear now? So how to find A union B whole complement, understood? If they said A union B whole complement, we can write universal set minus A union B. A union B completely removed from the universal set, then you will get A union B complement. That's the reason A union B complement is equal to empty. Clear? So now we'll go for A complement and then B complement. So let me go for A complement first. So what is A complement? How to represent only for this? So now let me go for A complement. Yeah, A. And this is B, 3, 4, 5, 1, 2, 6, 7, 8, 9, 10 and union. Right? So now observe carefully now what we need to do. A complement means U minus A, means completely A need to be removed. So completely A is this line skip with the union, whichever the intersection part is there, that also. So this completely, this A part need to be removed. So whichever empty space is there, that is your A complement. Same method, B complement means, here I will draw union. So A and B. So here 3, 4, 1, 2, 5, 6, 7, 8, 9, 10. Now B complement means completely remove the B. So if I completely remove this B with the intersection part, so whichever the empty space is there, that is nothing but your B complement. So now we found A complement, B complement. Now we'll go for last one, A intersection B whole complement. So we'll go to that. A intersection B whole complement. Okay, so A intersection B whole complement. So first draw a rectangle, this U, and it is A, and this also B, and anyhow this is, let me draw a little more bigger. So it is 3, it is 4, 5, 1, 2, 6, 7, 8, 9, 10. Okay. In this, observe carefully now. A intersection B complement means U minus A intersection B. Total A intersection B should be removed. So now let me keep your lines. Whichever left, that whole empty place is A intersection B whole complement. So you are understood now. So this is about your total Venn diagrams which are possible to ask in your examinations, but still we need to understand some more with the diagrams, which are the important one is there. So meanwhile you complete it by writing. So just I'll give for you some 10 seconds, then after that I'm going to explain to you another. Okay, now we are going to discuss, okay, one more diagram. I hope you all completed. So now I am going to write one more one, that is what are disjoint sets, how to represent the disjoint sets in a Venn diagram. Disjoint means what I said for you all, there is no common element. So if there is no common element, what to do? Observe carefully here. Okay, so now we are going to discuss what are disjoint sets, how to represent the disjoint sets in a Venn diagram. Okay, so now let me draw now. This is now union. Now this is A set and here it is B set. Now observe, is there any common area? So there is no common area. That means that these sets are independent, not dependent. So that means there is no common element in the both sets. So we can say this as disjoint sets. So disjoint sets. So this is your disjoint sets. Okay. So I hope you are understood how to represent disjoint sets. If you want, I'll give one example. A is equal to 1, 2, 3 and B is equal to 4, 5, 6. You check, there is no common element. And then 4, 5, 6. Okay. So I hope you are understood how to represent the disjoint set. Now we'll check if any other they given. Okay, A union B completed, and represent these all, some of the diagrams which they given in your textbook, those we are going to discuss now. Okay, right, let we discuss now. So now first one, it is they asked you to find They were not found anything in this case that anything equal to was given. Let me check back. They said to you, prove that A union B whole dash is equal to A dash intersection B dash, and A union B whole dash is equal to A dash intersection B dash. This I need to prove. How to prove? Just observe carefully now. Let me prove that. So we'll prove it. First, you already know A union B whole dash. What is A union B whole dash? U, and it is your A, and it is B. A union B whole dash means U minus A union B. So total this A union B removed, then whichever you get, that is empty part, is your A union B whole dash or A union B complement. This dash or C, whichever they given, that is complement only. Okay. So now A dash intersection B dash. So now previously A dash B dash we found, but right now here it was nothing was there. Okay. Again I will show to you what is A dash and B dash. Then you can understand that clearly. So now I can write here it is first A dash or A complement. So let me draw for you all A B union. A dash means U minus A. So U minus A means in the universal set remove A. Completely this A is removed. So that empty part is going to be your U minus A or A complement. Same method now, B complement. So now A, B union. So now whichever the empty part it is, B complement. Now what they said here, A union B whole complement is equal to A dash intersection B dash. So A dash and B dash, both places, which is the common area you are found. So you found in both this common area, this part whichever left. So here A is not considered, here B is not considered, remaining whichever is there, that is only your common part. So if I write that, if I draw the diagram, here I am drawing that, it is your U and A and B. So if I check the common part, so this empty part is the common part, that is A complement intersection B complement. So common area we need to find. Here common area we found in both is this, whichever the outside of these two sets are there, that is only both are common. Because here B is not common, the reason here it is B is there. And here A is not common because in this place A is there. So only this empty space whichever left, that is your A complement intersection B complement, means that is your common area. So that common area is that, so A complement intersection B complement, and check this also. Now A union B whole complement also check. These both are same diagram. So we can write this as equation 1, this as equation 2. So we can write from 1 and 2. So A union B whole dash is equal to A dash intersection B dash. So that is about your Venn diagrams. All the important points we covered in this Venn diagrams, all the important diagrams which they are going to ask in your examination, everything was explained in this place. So thus we completed all the concept of chapter number 1. Okay, so then next class, whenever the next live, so tomorrow we are going to discuss about our total first exercise we are going to solve, and if you have any doubts, you can ask me immediately after watching this video through the WhatsApp. Okay, may God bless you all.